Welcome to part 3 of carbohydrates and how to draw various monosaccharides. I am Dennis Roberts of Dr. Chem Tutoring Service. What we're going to discuss today is how do we go from the chain form to the ring form of monosaccharides. And to do that, it's best to get to the Fischer projection first. So if you start with the bond line structure, you want to convert that to the Fischer projection. And in my previous video, we did just that. So starting with the Fischer projection, what you want to do first is kind of redraw it so that the bottom is going to be an OH and not the CH2OH. So we have to rotate this in this scenario clockwise. So the OH will go down here, the CH2OH would go to the left, and then the hydrogen would go to the right. I rotated it, so I still kept the same stereochemistry. If you just switch these two, that is creating an epimer. So make sure you are actually rotating all three of those pieces. The rest of the molecule is going to stay the same. Once we did that, we have to do something else. We want to push this down on its side. So I'm going to knock it over now so that the aldehyde, I'm going to now write it out as the aldehyde, is here. And because I pushed it over, all of these things are going to be over here on the bottom. So when I draw this out, I would have my OH here. That hydrogen's up. So 1, 2, 3, 4, 5, 6. 1, 2. On the third one, the hydrogen is going to be down here. So the OH is up there. On the fourth one, we have the OH is going to be down here. Hydrogen is going to be up here. And on the fifth one, my OH is going to be sticking out because it's in line. And I will have my H going down and my CH2OH going up. When you form a ring, this is going to go behind all of this and attack that carbon from this backside. When it does so, this OH, or this oxygen of the double bond, is going to become an OH. So the oxygen here, which was originally here, is going to be part of the ring. And so if I draw a six-membered ring, it would look like that. Now notice the way it's drawn, anything here is going to be down, anything up over here is going to be up. So if this oxygen is here, going clockwise now, we have our 1, 2, 3, 4, 5, 6. So let's number those. 1, 2, 3, 4, 5, 6. Notice on carbon 1, that was my carbonyl carbon. Depending on whether that aldehyde was facing that way or this way, when that oxygen attacked, I could either have the OH going up or I could have that OH going down. If it goes up, it's going to be the beta. If it goes down, it's going to be the alpha. Either one of those could happen. So your professor may ask you to draw alpha or beta, or they may not specify, in which case sometimes they let you draw a squiggly line with the OH instead, saying basically it could be either or. So that first one, we only know where it goes if they tell us where they want it to go. But starting at carbon 2, notice that OH goes down. It's going to be down in my ring. The carbon 3, OH goes up. It should be in the up position. The down position would have been the axial. Carbon 4, OH goes down. It should go down. Carbon 5, my CH2OH, goes up. So for D sugars, you should realize that this piece will always go up in a D sugar because of the positioning of that last chiral center. Now there's other ways to draw these. So I drew it in the chair conformation. Another way you can draw it is in the Hayworth conformation or in just a bond line sort of hexagon structure. The Hayworth projection is kind of like this. Again, this is my oxygen that was here. It forms a bond to the carbonyl carbon, which is this guy right here at 1. Depending on how that carbonyl is rotated, that could either be a dash or a wedge on 1. I'm going to put a squiggly line indicating that it could be either or, depending what they ask for. Carbon 2 is a OH going down. So in the Haworth projection, you just either draw things up or down. So the OH would be down. On carbon 3, it goes up. On carbon 4, it goes down. And on carbon 5, that CH2OH goes up. So this is the Haworth projection where you draw kind of this hexagon sort of structure, but draw things up or down relative to the vertical point. The last way we can draw structures is using dashes and wedges. So again, I could have drawn it like this. The first structure 1 could either be up or down, whether it's alpha or beta, I'm not going to specify. 2, it goes down, down is always dash. 3 is going up, wedge is up. 4 is going down, dash. 5 is going up, wedge. So this is another way we could have drawn it. All three of these are technically acceptable. It just depends on what your professor wants. Keep in mind, I didn't show specific stereochemistry on 1. If I wanted alpha, remember alpha is going to go down, beta would be up. So if I did this, that would be the beta form. Oh, sorry, that was the Haworth. If I want to show the beta form going up for the Haworth, I would do this. If I want to show the beta form for the bond line, I would put a wedge there. Also, keep in mind that another thing I had done, was I only showed the OH groups. Typically, when you draw the chair conformation, you draw the Haworth conformation, or you draw the bond line structure, we typically don't show the hydrogens because they take up space and make clutter. We typically only show the substituent pieces. Now, again, keep in mind that you could be given this structure to begin with. You could be given the ring structure. How would I go from the ring to the Fisher projection? Well, there's several ways to do it. If you're fine looking at a chair conformation, you can identify this as down, down, up, down, up. And remember, we number the carbons 1, 2, 3, 4, 5, 6. So if I were to draw my Fisher projection, CHO on top, that's carbon 1, then we have carbon 2, then we have carbon 3, then we have carbon 4, then we have carbon 5. Now when I draw it first, I like to have the OH down here because that's how I explained it in the other one. Because then it's easier to see, remember when I tip this over, anything over here would be down, anything over here would be up. So using our ups and downs from before, carbon 2 is going down for the OH, down is the right side. Carbon 3, OH is going up. Carbon 4, it's going down. And carbon 5, it's going up. Put my hydrogens in. This is my rough Fisher projection, but remember, we want this to be down here. So we have to rotate that bottom so that we reposition all three of those, rotating them, so all of them have to change. So essentially our hydrogen's going to be on the left now. Our CH2OH moves back down here, and our OH will move there, and here we have the Fisher projection. Notice I did nothing with this carbon 1. That carbon 1, again, that up or down, it is all dependent on how this oxygen adds. And it is in equilibrium, so it goes back and forth. Carbon 1 is the carbonyl. When I draw my Fisher projection, it's back to an aldehyde. So there is no stereochemistry for that one. So it doesn't matter if it was up or down in my structure in the ring form, because when it goes back to the Fisher projection, it is no longer a chiral center. There is no left or right, up or down, or anything like that. So that's how we go from the chain to the ring. And again, it's easiest if you draw things in the Fisher projection. And if you are given things in the bond line structure, watching the previous video again will show you how to convert between one and the other.